Hello everyone, today we'll be solving problem number 213, house robber 2 here. So what the question states here, you are a professional robber and you want to rob houses along a street. So you have to rob the houses along the street. What are the conditions? However, the houses are arranged in a circle. They have clearly mentioned here, the houses are arranged in a circle. Just give me a second here, 1 second. So the houses are arranged in a circle, and which means the first house is adjacent to the last house. So suppose if we have three houses, one here, so let me give two here, sorry, just give me a second here. Yeah, okay, one is here, two is here, and three here, and three and one will be adjacent here, right? The first one and the last one is adjacent here, right? You can clearly see here, right? So that's what they have given here. So the houses are arranged in a circle, which means the first house is adjacent to the last house. If you rob two adjacent houses, the police will be alerted. So here you can clearly see 1 and 2. If we are robbing 1, then we have to skip 1, and also we have to skip 3 in this case. So because police will be alerted if you are robbing the adjacent houses, right? So that's what they have given in the question. So if you rob two adjacent houses, the police will be alerted. You are in a given integer, you are given an integer array nums. You can clearly see integer array nums, where iterated value of the nums represents the amount of money in the ith houses. So in the first house we have this one amount 2, in the second house we have amount 3, and in the third house we have amount 2 again. So this is 0 indexed. So the nums array is 0 indexed, index 0, index 1, and index 2. Just keep this in mind, right? So we are given an integer array nums where iterated value of the nums represents the amount of money in the ith house. What is our main goal then? What we need to do? Our goal is to find the maximum amount of money we can rob without alerting the police. So without alerting the police, what is the maximum amount of money that we can rob, right? So we shouldn't rob the adjacent houses. Instead, we have to rob this one, alternative houses. And also one more condition is, as the houses are in circle, suppose if we are having four houses, so the first element of the first house and the last houses are adjacent to each other as well. These two conditions we need to consider. One thing is, we shouldn't rob the adjacent houses, and the second one is, first and last houses are adjacent to each other. So I hope the question is completely clear. In this case, let's come to the first example here. 232 they have given here. So what we will do, we can rob this one 2, and we cannot rob this one 3 or 2 initially, right? So if we rob 2, then we have to skip the adjacent, and the last house is also adjacent. So 2 will be the answer. So here in this case, if we consider 3, robbing 3, let's start from here, this one, robbing 3. Then what we will do, we will rob 3, then we will not consider anything. In this case, 3 is maximum, right? So you cannot rob house 1, money equals 2, and then rob 3. So money equals 2 they have given here because they are adjacent houses. Any one you can. In this case, 3 we can. So the maximum amount that we can rob here is, in this case, is 3. So that's what they have given here. Similar thing, same thing goes with the example 2 as well. 1, 2, 3, 1 they have given. Explanation they have clearly given here. Rob house 1. First house we are robbing, right? Where money equals 1. This one, index 1. 1 we will consider, okay, 1. And then rob house 3. So we will ignore, as this is adjacent house. So the value 2, we will ignore this one entirely. Let me delete this one. So we are robbing the house 3, that is money equals 3. We will consider this one. So 1 plus 3 it will be. Next it will be adjacent. The last house will be adjacent to first one, right? So we will ignore. If we consider house 1, then we should not consider house 2. Here same goes with here as well, example 1 as well. If we are considering the first house, then we are not considering second house. If we are considering the second house, then we are not considering the, if we are considering the last house, if we are considering first house, then we shouldn't consider last house. If we consider last house, then we shouldn't consider the first house. In this case, it is 1 plus 3 is nothing but 4. That is the maximum amount of money that a thief, this one, that we can rob, or a thief can rob here. I hope this is clear. I hope the entire question is completely clear. So initially what we'll do, we will discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's go with the so here let's discuss the approach step by step. I have considered the same example that they have given in the question, nothing but the first example that they have given in the question, right? So this is one thing, first example. Sorry, just give me a second here. Yeah. First example, the approach that we are going with here is dynamic programming or DP. Let me write here DP. So we will be solving this question with the help of dynamic programming or DP. So let me write here dynamic programming quickly. So the question that I have considered is the first one that they have given in the question, so that it will be easier to understand. We have three houses here, right? This is index 0, this is index 1, and this is index 2. This is value 2, 3, and 2, which is circular, right? The houses are circular. So output we have to get here is 3. Let's move on with the first step. So here we have to consider this thing. Houses are arranged in the circle they have given in the question. So we will consider the circle here. In this case, 2 I have considered initially. 2, 3, and 2 houses are there, right? These are the three houses we have with the money destination. Money, the first house consists of the amount 2, the second house consists of amount 3, and the third house consists of amount 2 here again. So if we are considering the as we are going with the, since houses are in circle, or as we are considering houses in the circle, we break this one into two cases. So we have already discussed this one, yet let's make this one clear so that it will be easier to compute further, right? Case 1, we have to exclude the last house if we are solving this one 2, 3. The first house if we are considering, we have to exclude the last house. So if we are considering the last house, then we have to exclude the first house, right? If we are considering first house, then we are excluding last house. If we are considering last house, then we are excluding the first house, vice versa, right? So exclude last house means only we are considering 2, 3. Exclude first house means we are considering 3, 2. I hope this is clear. This is the main step we need to understand. So let's go with the case 1. Here in this case, we are excluding last house. So out of array we had was 2, 3, 2. So now we have only 2, 3 because we are excluding this one, last house. We are excluding the last house, 2, 3 we have. So we will apply DP to find the maximum amount we can drop. Nothing but we are applying dynamic programming here. So house first we have 2 and house second we have 3 here. Money should be 2 and 3 in this case. I hope this is completely clear, right? We are considering for 2, 3 itself. So money we have here is 2 and 3. First house consists of the amount 2 and the second house consists of amount 3 here. So total this will be 2 and this will be 3 here, right? So the max money that we have robbed from this one, case 1 is 3. You can clearly see 2 and 3, the maximum one is 3 here. So maximum money here is 3. Let's write here maximum money robbed here is 3. So let me give the same thing here. Let me do one thing. Maximum amount robbed. So this one let me consider here. This is fine. So here we are considering case 2, robbing from 3, 2, nothing but the second case here. We will exclude the first house in this case. So we had here 2, 3, 2, and first this one we are excluding. Now we have only 3, 2. So we are considering only 3, 2 as we are excluding the first house. In the first house we have the money 3. Let me consider here. In the first house we have the money 3 and in the second house we have the money 2 here. So the total will be 3 and 2 in this case, right? So which will be the maximum here? You can clearly see 3 will be the maximum here. So the maximum amount dropped in the second case is 3. So the final step here is final output here is, since we cannot rob both the houses we cannot rob, house 1 and house 3 together we cannot rob this one, house 1 and house 3. Either we have to exclude house 1 or either we have to exclude house 3 here. So we can just take maximum of both cases. So both we will calculate, and out of which, so out of the two cases we have to take maximum here, right? So suppose if we take the maximum, that is the maximum amount that we can rob accordingly with the question they have asked here. what is the maximum here in this case? In the case 1 is 3, and what is the maximum amount here robbed in the case 2 is 3. So we will consider here 3 comma 3. In this case output will be 3, right? In this case output will be 3, max of 3 comma 3, anything. For this example you can consider any number because they are equal right here. The amount stashed here is the amount that we got here is maximum amount that we got here is 3 comma 3. You can consider any one, so the output will be 3 in this case. So that's what they have given in the output in the example, output 3. So this matches this one, so the approach works absolutely correct in this case. So this is the approach that we will be going with. I hope this is completely clear, man, right? So next let's discuss the edge cases one by one very quickly. So the first edge case that we'll be going with here is single house. When I say single house, I have considered only one element, one house with the amount 5 here. So 5 output will be 5 itself. Why the output here is 5? Because only one house to rob here, right? So that itself will consider it will be 5. So this is for the edge case single house. Next let's go with the two houses. When I say two houses, we will go with the we will go with second one. We'll go with the condition two houses. So we have the, for first house we have the amount 2 stashed in it, and for the second house we have the amount 3 stashed in it. So we will be considering 3, right? If we consider first house, we cannot consider the last house. If we consider the last house, we cannot consider the first house. So we can consider any one of the houses. In this case we will consider 3 because that is the max, right? Maximum of 2 comma 3, it will be 3, right? So in this case I hope the second condition is clear. So let's move on with the third edge case. All houses have the same money. Here you can clearly see. So first house have 10 stashed in it, second house 10, third house 10, and fourth house also 10 here in this case, right? So output will be here. In this case the output will be 20. So why the output is 20 here? This one we will drop. If we consider first house, suppose we'll go with the two cases. First house, so here this will be 10 and we will ignore the alternative one, and then the last one also we cannot consider here. So first case we will get 20. So let's go with the last house, right? When we are considering the last house, we will start with this house 10, and we will come here, this one 10 plus 10 here. As we are going with the same this one same amount in every houses, it will be max of 20 comma 20. So max of 3 comma 3 itself we got in the first example that they have given in the question. Similarly to that one, here we have max of 20 comma 20. So the output will be 20. Anyone you can consider, this will be 20. So this is for the edge case all houses have same money. Next let's go with the edge case increasing order. In this case 1 2 3 4 5 we have. So here we can rob house 2 and house 4. So this 1 0 1 2 3 4, I'm just considering the index here in this case. So I rob the index 2 and index 4, nothing but house 2 and house 4 here. In this case it will be 3 plus 5, right? It will be 8 in this case. You can just visualize in the same way like this we did, right? So let's move on with the final this one final edge case decreasing order. So here you can clearly see amount we have 5 4 3 2 1 in the respective houses. So same thing, here we will rob house 1 and house 3. House 1 means 0 1 2, indexing starts from 0 here as this is 0 index. So house 1 and house 3 here is nothing but this one 4 plus 2 here, nothing but 6 in this case. So the output will be 6 in this case, right? So I'll just give here. So yeah, the output will be 6 here. So this is the approach that we'll be going with, and I hope all the edge cases are clear as well. So what are the edge cases that we discussed now here? The first edge case that we went with here is single house. The second edge case that we went with here is two houses, and the third edge case that we went with here is all houses have the same money. The fourth edge case that we went with here is increasing order, and the fifth edge case that we went with here is decreasing order. So I hope all the edge cases are clear here. So let's start writing the code. So let's start writing the code here. The first what we will do, we'll consider if there is only one house, then we have to return its value, right? So this is simple. If there is only one house, then what we will do, we will return its value. this one will be nums.length less than 2, then we will return nums of 0, nothing but the first house value itself, or 0, right? So I hope this is clear. If there is only one house, we will just return its value, simple if condition, right? So next we will be making use of the helper function. I'll just name the function dp. In this case, we'll go with the helper function just to compute the or calculate the maximum amount or maximum loot for a linear row of houses. We have to loot a linear row of houses, right? We have to skip the adjacent ones, and we have also we have to keep in mind first, and if we are considering the first house, we have to skip the last house, and if we are considering the last house, we have to exclude the first house. So these two things, just keep this one in mind. We are making use of the helper function to calculate the maximum amount for a linear row of houses. So let me quickly write here const dp. Let me pass the parameter array here. This is fine. So here let a equals 0, let me give, and b equals 0. This is nothing but initialization initially. So for loop, let me go with. So let me go with the for loop here. Let n of array. So here within this, what we will do, we will store the previous maximum amount, right? So for that, I'll just consider the temporary variable. Let's give temp equals b here initially. So a and b are the variables we have considered. We have to store the previous max, means this one. Previous will be this one, in this case b, right? So let's initialize temp to b. Then we have to choose maximum of robbing or skipping the house, that we have to do, right? So how can I articulate that one in the form of code? Yeah, b will be math.max of a plus n comma t. This is fine. What we are doing here, I hope this is clear. Don't get confused here. We are just choosing the maximum of robbing or skipping the house. I hope this is clear. So the next step here is, let's assign the a to temp. So why we are assigning the a to temp? Because we have to move to the next house, right? After choosing the maximum of robbing or skipping the house, we have to move to the next house. For that one, we have already considered the temp here. This one, we have initialized the temp to be here, and in this case we are assigning a back to temp. Nothing but we have to move to the next house. That is the reason. So finally here, let me come here. Let's return b in this case within the helper function. So let me come out of the dp function entirely. Finally, what we have to do, we have to compute the maximum amount by considering two cases, right? Two cases were, if you remember, one case is if you are considering the first house, then exclude the last house. If you are considering the last house, then we have to exclude the first house. So how can I articulate that one in the form of code? So just give here return math.max of dp of, let's make use of the slice here from 0 to -1 initially. So this one is fine. I hope this is clear. Next step is, again, let me consider here dp. This is for the first case. Slice from 0 to -1, we have sliced, right? That is for the first case. So here we will be slicing till 1. Nothing but we are getting the maximum value. We are choosing the maximum value from both the cases finally, right? That's what we had done in this one approach, if you remember correctly. So this one will be nums of slice. Again, we will slice up to 1 here from 0 to -1. Here this is up to 1. We are slicing from up to 1, right? So I'll just put the semicolon here. So let me format the code once and hit the run button. I hope this works. Let's see. So you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming. Nothing but for the optimization purpose, we went with the dynamic programming right here. So the overall time complexity would be here big O of n. Why the time complexity here would be big O of n? Because we are iterating the house we are iterating over the houses twice, right? So we are iterating over the houses twice, case 1 and case 2. You can clearly consider this one. We are considering case 1 and case 2. So we are iterating over the houses twice, but iteration takes big of n, right? So overall time complexity we can just consider as big of n. So overall time complexity will be big of n in this case. So what will be the space complexity here? The overall space complexity would be big of 1. So by here the space complexity is big of 1, not the big of n, because we are using only two variables. You clearly see. So this is the optimization that we have done, or else it would have been big of n itself. So we are considering two houses, two variables here. One is a and b to store the results. So finally we are returning b here. So we made use of the temp, right? So this is one of the advantage. So this is nothing but DP optimization. So this one you can do for the space, right? For overall space complexity would be big of 1 if we consider two variables here, right, to store the results. So that is one advantage. So here overall space complexity would be big of 1 and the time complexity would be big of n in this case. I hope this is the time complexity and the space complexity or the complexities are completely clear. So I hope the code or the solution that we have written is completely clear as well. So for now this is it. Thanks for watching, guys.